This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Seeberg. Good morning. Not Monday, Tuesday morning
Tuesday
time,
morning.
Robert.
Yeah, we had some holiday breaks, and I was skiing. And at the same time, I visit our event location for AI in the Alps, and I can say it's not only beautiful in the summer there. Yeah, I'm really looking forward. Yeah.
Oh, skiing in April.
Yeah.
I'm going to start talking about carbon footprint, but it is difficult. I'm not sure. Oh yeah, sure. As you suggested. So you went skiing as that's what people here, at least in the south of Germany, but not only. I guess a big part of the European north, we have people, although the Swedish, Norwegian people have their own areas, but they come here as well, right? And that's, of course, always difficult here, depending on where you go, I guess, like how high the Alps are, if there is still snow or not.
We had a lot of snow. We had really a lot of snow.
Okay. Even in April, yeah. I mean, the weather is not too good at this moment. It's a bit weird in April. Should I just jump into the footprint thing here?
No, I will start. I will start because I have only one topic because, I was skiing. I was not involved in AI in the last week.
Oh, you were. All the times I saw you LinkedIn.
Yes, a little bit. But I don't know if you recognize it, but Amazon releases largest data set for training pick-and-place robots. That's very interesting. And the data set of image collected in an industrial setting features more than 190,000 objects, orders, magnitude, more than previous data sets. And the image, now it's a quote, the images in the data set fall into 3 different categories. The pick images is a top-down image of a bin filled with items prior to robotic handling, or transfer images are captured from multi-viewpoints as the robot transfers an item to the tray. And third one, the place image is a top-down image of the tray in which the selected item is placed. I will put the whole article and the data set in the show notes, and everybody can use this data set. And this reminds me to our episode with Jimmy from BMW and IDWorks. Yeah.
Daughter company, actually, BMW, but the BMW themselves also released a data set, and that was a more general industrial production environment, I believe, right?
Yes.
And this is
this is focused on bin picking and pick and place robots. Yeah.
Very interesting, right? Very, very interesting in how I actually need to give them a call today because some package wasn't delivered, but that is actually the point I do want to make, because until now, not for all of us, but for many, many of us, I'm a very regular, I must say, and then I come again to carbon footprint user of Amazon, and I'm not sure if that's good or bad as far as carbon footprint is concerned, right? Because all these packages in the cars, but then, there's not 100,000 people, going into town buying with cars, and maybe not, but let's not move there. And so they have been in most of our brains, a consumer, B2C, a provider of, goods, 10 years ago, books, and in these days, everything. And now they move into, obviously, B2B.
But it's not new for Amazon.
That was my question, right?
Yeah, they bought a robotics company called Kiva Systems.
Mm-hmm.
It was, I think, 10 years or 15 years ago for their own warehouses and to optimize their warehouses.
Mm-hmm.
And I don't know if they still use it, but they're investing a lot in logistics, and then they outsource this topic and want to sell it also to other customers.
Mm-hmm.
Yeah, but they want to optimize optimize their warehouses first, I think. Yeah.
And of course, we're talking AWS all the time.
We're talking about Amazon Science.
Oh, it's even another one.
It's another one, but it's part of this big company.
Okay, yeah, affiliate. But that is very important and very good, yeah. So, and then stronger than maybe even in, as you say, logistics, where they make themselves broad. I mean, and that's how they started, right? Again, talking about the number one, Amazon, we sell books brand. And then they started with the cloud, and they saw, we have, we have capabilities left over. Why not sell them? That's how they started.
Exactly.
Right? That's how the cloud concept started. Okay, interesting to hear.
Yeah, go on, Peter.
Yeah, I referred 2-3 times. So there's yet another study estimating the carbon footprint. And this time it's about there was one 3 years ago, and I had a very similar message at the time, but I'll get to that. This time they're looking at the large language model Bloom. Mm-hmm. Let me remind you, that's the one where over 1,000 researchers, they say, many different institutions, companies, over 50 languages, so then including all the European languages, right? It's 176 billion parameter language model. And this time it's Alexandra Lucioni from Hugging Face. They were one of these many institutions and companies. And they strive towards adopting the widely used, they call it LCA, Life Cycle Assessment Methodology. And that covers all stages of life cycle of a product or process. Okay. So you typically look at, how is it being designed and built, and then at the end of the life cycle, how are we going to get rid of it and stuff like that. So that feels like a good approach, right?
Yep.
At the same time, we have this Stanford University 2023 AI Index report.
Yeah.
You were skiing still. You may have seen it. We can talk about it later. Now, I'm only going to zoom in on one piece because they compare the Lucioni Bloom life cycle numbers to a single flight of one person, New York to San Francisco.
Wow.
And you can hear my, What is that about? I had a very nasty piece on LinkedIn. Didn't go through. Good for Stanford. Maybe good for me because sometimes I need to be careful. But I will say it now in a diplomatic way. Dear Stanford AI Index report publishers, you can compare apples to oranges. And I've said it before, I do that. I think that's a very useful thing to do. You can say, they're fruits. They are very similar size, but one is typically, maybe green or red. The other one is orange. That's good. That's science. It's looking and classifying and comparing. But what you do, I believe, you compare apples to elephants. And you don't mention it. No, worse, you compare it to, I believe, the biggest thing outside of Earth, planets. But because really, I'm convinced that if you apply what was very good, this LCA life cycle assessment methodology, then I believe you should compare the large language model life cycle to a plane's life cycle. So 30 or 40 years of a plane with an average on board, let's say a couple of hundred travelers on board. And that would result in, I have no idea, but it must be like 1 billion multiplicator on the side of the plane, right? I'm completely convinced. And the plane, of course, has then served, I guess, I don't know, a couple of million humans over these 30, 40 years. But against the large language model, that will have served, billions of humans. So just to be clear, I'm not against trying to be good to our Earth, right? I do my bit. I'm not very active, but I try to do my bit. But I really do expect a highly regarded research institute like Stanford to do better in their communication.
Yeah, absolutely. I haven't seen the report. What else is written there?
Well, actually, I saw it mentioned somewhere and I skipped through. Somebody did the, here's the most important. And I didn't see a specific thing that was structurally different. Maybe you and I have a quick look at it. And if there is something, we can still talk about it the next time.
Yeah.
So it was only indirectly that I think, is this, what did I say? Is this the third or the fourth one, maybe? So I recall in the past, it was all about US and China, Europe lagging behind and stuff like that.
Yeah.
And I expect, but I don't know. I would need to look into it. So I was only getting to, and I was really looking for this one foil, which again has not been produced by Alexandra Lucioni from Hugging Face. Mm-hmm. It's Stanford taking her numbers and comparing it to a single person. And I'm really, really looking forward. If one of you Stanford publishers of the report is out there, to get back to me, Peter at aipod.de, and explain me why it is that you do that.
Yeah, absolutely. What else do you have?
Oh, you may have heard you were in Austria, closer to Italy. So
I know what you want.
They banned the use of ChatGPT, despite the fact that what I saw, actually, they have a document on their approach to AI safety. Not going to go into the details, but they have, for example, that was interesting. They say they want to protect children. They say people must be 18 or older, or at least 13 or older with parental approval, right? Because that was one of the reasons. Also, they say they have, actually, GPT-4 is 40% more likely to produce factual content. GPT 3.5, there's still problems there, of course. I'm just saying, and by the way, there's another message there, not going to go into the details, but ChatGPT can now access the internet and run the coded writes, ... I'm considering sharing that on LinkedIn just afterwards, but I'm not sure. It's almost like, and of course, you and I now here as well, we need to go back to normal business as well. Not only, but then again, I mean, this thing is havocing the world, right? So,
but I thought that the Italian approach is a data security topic, right?
Sure. It could only be, right? I mean, of course, from the perspective of the European GDPR, there was a breach. There was a breach. There are certain, I believe, payment details, because of a technical flaw, came into the hands of other people. And that's, of course, it's a no-go. Now, that happens, I guess, everywhere. But that was not the only thing. I think there were other general reasons raising concerns that the system was sometimes generating false information, as we just mentioned and have discussed many times. And they were also questioning whether there's a legal basis to collect massive amounts of data. So they have been talking, they've been on the phone together, I understand, and openly I say they will, as good as they can, apply to the requests that come from Italy.
Okay, I had a little chat with Gary Marcus during my skiing holidays. I invited him in our podcast, and he said, maybe in May, April is just hopeless. He has a lot to do, I think, in the moment.
Oh, yeah.
So at the end of the month, I will write him again to fix the recording with Gary.
Gary was exactly the next on my list. So he's like you are like him, because he actually was saying a week ago, and I'm talking now about the request for a 6 months moratorium on large language models, right? And he was, of course, part of that. Not sure that he was the initiator, but he jumped on the bandwagon. He said it was not perfect, but better than nothing. And I believe he may last week, the week before, have been on holiday as well. And he was saying, nevertheless, I have a day off, but I have to do something here. So there is this moratorium, and he is one of the well-known researchers in AI space that signed it. But at the other hand, and there is one side that says this is not going far enough, but there is the other side as well, right? Not sure if you've seen, there's Andrew Wang and Yen LeCun yesterday, the day before.
They did a podcast, right? Or a conversation or something.
Yeah, it was a live, actually. It's interesting, on
YouTube.
There you go. Yes, I was in this platform, YouTube, and there they were saying live, and I clicked in. I didn't stay for, I don't know how long they were. I just want to say, yes, there is the discussion on the moratorium. They get support, but it's very two-sided, right? Some say not far enough, and the others say, oh, keep your fingers away.
But what is the opinion of Andrew and Jan?
No, they're against it. Both
Yeah.
of them are against it. Yeah. So
But why do you initiate a discussion between two people who are against it?
Yeah, that's a good point. That thought just came a millisecond into my brain as well. Yeah.
That's not interesting, I think. Yeah.
But I do believe that I am correct in saying that both of them do not support the moratorium. That's a good point.
Andrew, a little bit, I think. I'm not quite sure.
Oh no, they do. No, they both do not. Okay. And if I'm wrong, then afterwards, then we have to record this again. But no, I think they both say no, you can't. It's
I think it's very interesting because Lacan always compare it to the printing when the printing was developed. When the church do not want it that books are printed. That's he compares this. Yes. Yeah.
Oh, right. Okay. And I believe that Andrew has been the first one to compare, well, let's see at what level, artificial intelligence. So more like a year ago, let's say, when other AI became big. And he's the first one, I believe, to compare to electricity, right? And now you see many other people doing that. Sure, I have a final one here, and it does relate to an interview by Lex Fridman with Sam Altman, another YouTube thing. Lex does these. You sometimes complain that I do, like 3/4 or an hour interviews. Lex does these 2.5 interviews. I've listened to an hour. There was another interview. There were so many that you can't read and listen to all of it. But of course, here you go. Jeff Hinton with, I believe it's CBS. Is it CBS, called Saturday Morning? And I was reading through, and I think it's a very good interview. I leave it to you. Maybe we put the link, but look at for Jeff Hinton interview CBS, and that's the interview where he was asked, can he imagine that, I don't know the exact wording now, but that life is going to be destroyed by. And then he first says he's not certain, between 0 and 100. And then he says his famous words is not inconceivable, which almost sounds like very British, diplomatic.
Yes.
Who knows? Could be. He keeps it open.
What is your opinion on the moratorium?
I would not support it, I believe, in the end. Of course, I mean, I've been requesting regulation for, as long as we work together from the very beginning, written down everywhere. We need regulation. And only regulation where it's necessary. And I've been talking about, and this is always so uninteresting when people, I told you. Yeah, but I did, 3-4 years ago, we're going to have these words put into people's mouths. We're going to have these images, and now it's happening. And that's really a little bit scary. We do need regulation, if not for any other reason, that you're not allowed to produce an imagery or wording of other people that is not you, and have them say something. I'm not sure. I cannot really imagine that there is certain regulation there today. And I think we need that very, very fast, because if not, it is.
Next week we will have an episode on regulation with the guys from Applied AI and the AI Act. We will talk also about that.
Oh, yeah, very good. I still need to share them as well. Yeah. So that's what I do believe we need. Yeah, of course now. I mean, and also LinkedIn and all the social media are swarmed with imagery of things not happening. And now it's interesting, kind of, let's say there's a plus, negative. The plus is like that now suddenly everybody can see what can be done. But I'm sure that this is, exponential, bringing people to the table, doing the same thing, until the point where in the near future, if you see the Pope in in a white
ski jacket,
skiing jacket or whatever, then maybe that's a bit weird, and all these things. But it's now the coming days and weeks and months, what's going to happen to imagery, and people are going to believe nothing again. So, but does that mean that we shall stop? Oh no, we have so many examples in the past where, when urane was invented, when was that? 100 years ago, it was clear with many researchers from around the world, I believe kind of from day one, when they saw that this was now happening and this potential of producing energy was capable, it's certain to me that they will have considered at the very same time the negative potential of this new technology as well. And that's what OpenAI and all the other ones try to be very good with. If they did it the right thing, I don't know. You could almost say poor Sam Altman with this huge responsibility on his little shoulders, so to say, right? So let's see.
I think the genie is out of the bottle. You can get the genie back in the bottle.
And that's the same then with uranium. We live in a country where we still have only, a handful of nuclear plants, thanks. Other countries build more. That's the state of which we're in. It's the same thing with AI-based warfare equipment, with chemical equipment. We have 196 countries in The Hague, in the Netherlands, who say, we're not going to be using this awful technology, so to speak. So let's see how far we get with EA. I had a final one. We talked about job killer, generative AI, several studies.
And new jobs.
Yeah. So if you are, very specifically, there was a German piece here that said if you're accountant, my dad was accountant, mathematician, maybe that could be, listeners, programmer, that's, very likely programmers listening to us. But if you're an interpreter, if you are a writer, journalist, not likely, although this is the area of those of you in the marketing communication space of AI, maybe. You may have heard it through the grapevine. You may have had your personal thoughts considering, maybe I should change to become and they say if you are going to be a cook, a car mechanic, maybe you want to take a job in oil and gas. I'm not sure why that is. Forestry, agriculture, you're better. Or, and that's the thing I wanted to share, you may have heard of this prompt engineer. You can earn up to $335,000 a year, if that's important to you. And interestingly, in this interview with Sam Altman says, he's not good. He's not good at creating prompts. I think the prompt creator is the first well-known new job that I could have never, ever considered and thought about.
But can you describe what the guy is doing?
Yeah, it is, how can you best ask questions of the large language model to get maximum out? And you can read by all these guys, women sharing their experience on, where I'm LinkedIn all day through. And they explain that you cannot ask general things. And as we know, the general questions, when did Christopher Columbus arrive in the United States and stuff like that, it's not good at, and was never, I believe they should have never kind of allowed that anyway from the beginning. I understand that you have to be more specific. My very first understanding is you have to say, and now you have to say, and in the future you don't have to say anymore. It's all about personalization. You have to say, I'm Peter Seeberg. I'm this and that old. I'm married. I got a kid. This is my job. You have to give the language model a little bit of, and maybe not of yourself, but of the thing that you're interested in. So you have to give it a surrounding so it can work with the surrounding, and then it can give you, I believe, and that is a 0.0 kind of idea. And if this is what it is, the prompt engineer helps to get the maximum out of the large language model.
That's really interesting. And now we switch into the main part, and you did an interview with Stefan Suwelack, right?
Yeah, and Stefan Suwelack, CEO of Renumics, he and his team, they do what also at the same time, Andrew, we talked about him, Eng does. I think he's made it probably famous. We do quickly talk about him as well, but in this case, it's about a Germany-based company, Renumics, and they do data-centric, basically. It's about do not try to get the final 1, 2, 3, 4, 5% improvement through improving your algorithm, but concentrate on boosting your data, making sure that the data have high quality.
Perfect. It was a pleasure, Peter. Thanks a lot. And now enjoy the main part.
Robert, thanks. Have a good day. Talk to you soon. Hello, Stefan.
Hello, Peter. Thanks for the invitation. Really glad to be here.
You're welcome. Let's start. Please introduce yourself to our listeners and let us know what you do and at the same time, tell us a little bit about who Renumics is.
Yeah, thank you. My academic background is actually in numerical mathematics and medical informatics. And as you said, I'm co-founder of Renumics, and Renumics, we help our partners and customers to build industrial AI applications that generate value.
Sounds great. We're going to concentrate on industrial as we are the Industrial AI podcast. Interesting, though, to hear that your background is from medical. Maybe we can chat about that somewhere later. I mean, all the different areas, one way or the other, through data, which is our big topic, growing together, right? So why should listeners consider boosting industrial AI by boosting data?
Yeah, I think it's no secret that obviously to build robust machine learning based solutions, you need great training data. And I think this is pretty obvious and pretty common sense. What we feel is not obvious enough, that you need systematic and iterative approaches to build these great training data sets. This is something that where Andrew Ng coined the term data-centric AI. I think we will go into detail about that a little bit later. And where we really feel that this is the biggest key to building successful industrial AI solutions.
Yeah, you already mentioned his name there. So I'm not sure, but you can share that. Was Andrew Wang? Yes, you may have heard our podcasts before, those listeners that I wasn't sure many years ago. And, I kind of got into the specific business of the machine learning probably 7-8 years ago by doing Andrew's training on the introduction of machine learning, I believe was called, right? With this very weird picture of a professor with a hat, something like people who've done his course will recall it. I think it still has this weird picture. Was it Andrew who started it? Was it more a general, people around the world, whenever things are come to a certain point, at different points on our globe, people start doing the same things? Or since when is this data-centric approach happening?
Yeah, I think the latter is completely right. I think it's something that where the collective community realized something and he gave it a name. And I'd be really glad to share a little bit, how we realized that and how the overall machine learning community realized that.
Please do.
We actually started off building solutions that automate simulation processes in the automotive industry. This was where our academic background came in, right? We actually built simulation systems for medical applications. And there, what you typically do is you have to build a different model for each patient. And you do this by applying machine learning to MRI imaging or CT imaging. And then we found that in the automotive industry, building simulation models from CAD, normal computer models, is actually it's a lot of work. It's a lot of manual work. And machine learning can really help to speed this up. So this is where we started with Renumics. And actually, no matter the project, what we found is that typically the story was, we have so much data in our simulation database. And then when we look into this, we typically find that the data is highly fragmented, outdated, and you really have to inspect it and understand different cases, edge cases, and you really have to communicate with the domain expert well in order to make sense of it. And this is a lot of work, and this is typically what's the most work in a project. So this is where our journey started about how can we make sense of unstructured data to build machine learning systems. And at the same time, I think the machine learning community realized this as well. If you go back to 2012, where we had this ImageNet moment, and maybe you could say deep learning was maybe not born, but put on the map. For a couple of years then, the story was basically, if you're a PhD student and you want to write a new paper, what you do is you take these benchmark data sets, You build a new algorithm or you tune one, and then you say, well, my algorithm is 0.2% better in this metric, and you build a new paper, right? And then what's interesting is that I think in 2020, around 2021, suddenly some highly visible papers came out that actually asked the question, well, we've been working with this benchmark data sets for so long, but how reliable is the data actually? And they found that there are a lot of duplicates, even leakage between test and training data. So in short, the data sets are flawed. I mean, everybody, I think it came probably to no surprise to anybody. But I think it was surprising that it took like 8 years to really go systematically about how can we assess the quality of these benchmark data sets. And I think this is what also our observation is from our work and the work we see with partners and customers and other teams, that everybody had already known that data quality is important, that iterating data is important. But even today, very few teams go really systematical about this. And I think this is the big leap that data-centric AI is providing.
Right. It's a very nice, very good overview, introduction. I hear, the concentration more on data quality rather than data quantity, or maybe both, but we'll get into that. But at least like improving quality of data next to, in parallel, or maybe sequentially, I hear, after the community has been concentrating for 10 years on improving models, improving algorithms. So I don't think it's saying like forget the algorithms, but I say don't concentrate on improving 0.00 something on the algorithm output measured as by XYZ. So this is how you explain out of the community. Why did it not happen in the past? Maybe from the perspective of application, and maybe what do domain experts have to do with the fact that this did not happen earlier?
Well, I think the role of the domain expert is very important in many, many domains, including in most industrial applications. And I think it's important to understand that at least most projects I was part of, the domain expert, it's not his day job, right, or her day job. It's something somebody like does on top to build something for the future. So typically domain experts have little time. That's the first thing. Then what typically happens is if you analyze data with machine learning, you will find inconsistencies. And this can be troubling for a domain expert because the domain expert says, oh, we have this great process. Everything goes really well here. And then you find inconsistencies and the domain expert has to explain them. And for some people, this can be difficult because maybe they are held accountable for something that was under the radar previously. And the last thing is that the tooling is obviously very different typically, right? Data scientist uses maybe a Jupyter notebook, and the domain expert in the industrial domain uses an equipment, a software from like a test equipment manufacturer or a CAD system, a PLM system, whatever. So then it's also like difficult to bridge this, where you ideally say, okay, we have to take a look at these data segments, but doing this can be really, really difficult. So I think keeping the domain expert engaged and having the ability to communicate in a very data-centric way, I think is the most important aspect in an industrial AI project.
Very interesting. Strong agreement. Listeners who've been here, have been listening before, will know I'm a big supporter of the central role of the domain expert. And very interesting. I hadn't considered how you make us aware of the fact that maybe the domain experts starting to get introduced to at what level, always at the highest level, but a little bit going down technology, applying machine learning, that then suddenly inconsistencies move up on top, which before obviously have not been important, I guess, if not, they would have been seen before. That's very interesting. And as you say, is doing this on top of his or her job. We'll talk about that throughout and towards the end, as these days everything seems to be changing. But as I say, we'll take it as it comes and see what this, as what we talk about today, machine learning, improving data quality, quality, concentrating on quality of data, what that is going to mean for the domain expert, plus also other people around data scientists. So specifically then, maybe you tell us what it is that you suggest to do, and how do you, what do you provide, and what does then in the end this domain expert or the data scientist do?
Yeah, I think I mentioned before that this like data-centric AI definition, going systematically and iteratively about training data sets, is already a good one. But for us, I think an extended definition is more important. We say that this iteration or this boosting of the data has to be done by leveraging information from trained models. And I think there is really the key where you can see that data-centric AI has a lot of potential in terms of speeding up the process, making it more iteratively, making it more robust, getting the domain expert more engaged. And this is because in a typical old-fashioned model-centric way, it's maybe a little bit exaggerated, but I think only a bit, is that you have this waterfall-like structure. You acquire a data package and you give it to the data scientist. Then the data scientist maybe performs feature selection for 2 weeks or data cleaning, and then you annotate the data. And then you train the model, and maybe it takes weeks or months before you train the first model, right? And it's just a step by step, and the steps are executed sequentially. And in data-centric AI, what you strive for is you would collect a little bit of data, just a little bit. You don't annotate it. Instead, you run, for example, some self-supervised learning that helps you extract information about segments that help you understand what you're dealing with. And then you can maybe leverage some active learning methods to just annotate a few samples. Or you can use pre-trained models and very simple classifiers to get your first model. So in essence, what you do is you try to close the loop from data to model results really, really quickly. And you use these trained models, the information you get very specifically. You get embeddings from deep learning models that give you information about similarity and data structure. You get feature importances, for example, that give you information about the behavior of your data. You get uncertainties that help you understand where you might collect more data, and so on and so forth. And by using this information, you can actually iterate towards your solution a lot quicker. And I think this is very important. And you end up with solutions that are much more robust because you won't do stupid mistakes like having leakage from your train to validation data, or having very different distributions in your training data and your real world data. And I really feel that this is like the strong point of data-centric AI. And this is really how developing machine learning-based solutions should be done. And what we do is we are trying to provide methods, best practices, and tooling for this. Because I think this is like, if you go into this doing of stuff, then having access to these tools is important. Otherwise, you can't close the loop that fast.
Just bringing it together, as I heard, it's a moving away from the old waterfall model towards a more iterative approach is what I'm here, right? We'll get into some specific details like leakage, maybe feature creep later on as well. And then the next thing I was going to ask anyway, so what is it exactly that you are? I think you're providing a solution. Tell us about it. It's called Spotlight. I've heard it's open source. What is it all about? Who is it for? Who can use it?
Yeah, so it's an open source, or more specifically open core solution that we've been actually developing for 2 years now. And we are just going the step of open sourcing it, which is amazing for me personally, because actually when we founded the company, we always thought about doing an open source product, where in this more niche engineering domain, this wasn't possible because you don't get the economy of scales there. For this kind of product, I think it is. And what Spotlight is, it's a data curation tool for unstructured data. So it helps you understand data sets that are not tabular, images, time series, videos, geometries, and so on. And in this domain for unstructured data, a couple of things are important. First of all, obviously, you can't compare data points as straightforwardly as in tabular data. You cannot just say, okay, it's an outlier because it's just a big value. And another thing that's important is in order to understand, so you have to have like other means, for example, embeddings to understand structure in the data. And then in the industrial setting, you typically have combinations. You have primary unstructured data, but you also have metadata on it. So you would like to combine this information to understand it. And you would like to inspect the data. That means that you really have to look into it to understand what's going on. And looking into it might take a look at this image. You might take a look at a certain event in a high frequency time series to understand where your model is performing well or it's not performing well, or where you have a lot of data, where you have an important edge case, and so on and so forth. And Spotlight is a tool that helps you do this with just one line of code going, and this is very technically speaking, from your data you stored in a data frame to an interaction where you can inspect and tag your data.
Sounds good. A little bit about, and Robert is going to be very much interested. We sometimes a little bit talk about open source, but Robert has a separate podcast actually on that very specific. So we're not going to go into the details, open source in an industrial environment actually. But in the end, just 2-3 lines here as well. The reason that you decided to do that and what does that mean? So it means that basically interested listeners and other people, they will be able to use your solution. And open source means they can also, depending on the license, they can change it as long as they make it available again to others. Or
yes, exactly. You can already install it, pip install Renumics Spotlight. And we're just actually in the process of moving like all the open source part to GitHub. And we feel that especially in this area, this is a win-win situation for everybody if you have this solution as open source where people can try it, can make it better, and where also a lot of people will benefit from this. I think that will not necessarily purchase a license, and maybe a student who does a machine learning competition, for example, but who can contribute to the development with ideas, with feedback, and with code.
Okay, a lot of developments, I believe, going on in this area of open source, which we are not going to talk about here. I'm sure that Robert is going to ask you sometime in the near future to exchange ideas with him on that very topic. So who are the users then of this solution? You know, are they, we talked about domain experts, are they data scientists? What are the people using your solution?
Yeah, the primary user is the data scientist, the data expert, machine learning expert, and they typically use it directly from a Jupyter notebook. And one of the most important design decisions for us in this context was that you can directly basically load your data into the tool without putting something in an extra database where you again have to version the data and so on and so forth. So this is the primary user we are developing for. But our customers also use it for their domain experts. And the way they do it is they have this data expert who prepares data and put it into the tool. And then in the tool, what you can do is you can basically configure the view, the interaction. And then the domain expert gets this configured view and can then browse and annotate data by herself. And this is definitely how it's meant to be. It's a bridge between, it's for the data expert, but it's also a bridge to the domain expert.
I understand that certain Python-based toolkits exist, which maybe do some of what you and your Spotlight solution, what is it that is, already maybe available? What is it that is maybe that you offer new in addition to what is maybe already there? Maybe you give us a couple of examples of what exactly then the data scientist, the data engineer, and or later then the domain expert does inside of your solution.
Yeah, sure. So in terms of what is available, the way actually we also started out is we use an application called Dash. It's from Plotly. Most people are probably familiar with this. The idea is you can build a web app with just Python code. And you have some simple mechanisms where you can glue together visualizations very quickly. There are other tools like this, Streamlit, for example, and they are very successful. I think was an amazing leap forward, this technology. But first of all, you still need some time to get such an app running. You also need time to maintain these apps, and there is a ceiling what you can do with this. Typically, what we experienced is that you start with something and it's great, and then it gets a little bit more complex, a little bit more complex, a little bit more complex, and then it falls off a cliff. And specifically for this topic, visualizing unstructured data, finding segments, making use of embeddings, uncertainties, feature importances, we felt that it's like too much effort of building this, even with these great tooling available from scratch for every project. And so we found a way to standardize it. So instead of spending hours or days coding, maintaining these apps that are then subpar, you can just really just have one line of code, load your data frame based data into the tool and start exploring. And you can also very easily make this accessible to the domain expert. So you can just get started very, very quickly and have a robust and performant solution.
Okay, as we're getting into more detail then, before you mentioned leakage. Maybe that is one example of how you can tell us how you deal with leakage. First, maybe what leakage is for those of the listeners that do not know, and how you deal with leakage in your solution.
Yeah, maybe if that's all right, I just make a little tangent here, because I think leakage is one of the problems you find in your solution that some people are not aware of. And I think this is generally a big problem. And it's actually also for us a problem when we talk to people and help them, like to try to use Spotlight. So people are trained in this model-centric way. They look at their quantitative metrics and then they say, okay, I have a F1 score of 0.9. They are not trained in actually understanding different data segments and understanding that there are segments where the solution performs well, where it doesn't perform as well. And they're not trained in actually looking into segments and singular data points to understand what's going on. And this can be very problematic. And one of these problems is data leakage, where you have data samples in your test set that are actually very similar, or sometimes maybe even duplicates of samples in your training data set. And depending on your use case and how the real-life data looks like, this can actually heavily skew your quantitative metrics. So in essence, what it means is that you are testing on the very same data that you're training on, but you're not aware of it.
Okay, and through your way of improving your data, your solution kind of finds out, points the user to actually this leakage.
Yes, I think this is an important task of data-centric AI, to point user, for example, to leakage, right? And I think it's very important to say that what Spotlight does, Spotlight just provides the visualization and interaction for this part. What you also need is you need an algorithm that maybe extracts embeddings from your data and then compares the two data sets and flags data points that are very similar. This is a pre-process you do, and there are amazingly good open source toolkits available where you can typically, if you know how to do it, can do this in just a couple of line of codes. And then you have like candidates for leakage, and then you use Spotlight to inspect it. And then maybe the domain expert says, yes, this is because of this and this reason, right? So this is the typical workflow to detect data leakage. And again, if you look at this, what we call like data curation cycle, you will find there are a lot of similar tasks like finding leakage within this cycle and this work. So you need to be aware that this is just one of the topics that's typically overlooked. And you need like 20 steps or so where you have to make sure that you did everything correct in order to trust your final solution.
Where does your solution run? We always ask kind of cloud, is it on site? Is it one solution fits all? You talked about segments. Is it one solution for any domain, more like a usage, NLP, computer vision, and or, automotive or medicine?
Yeah, great question. Thank you very much. When we look at the history, how we developed the tool, we started developing something like for our use. So we started developing it for for use cases we dealt with from industrial AI, for example, dealing with geometry data or with acoustic data. And this is still like a very strong point of the software right now. So the overall setup is in a way that's very agnostic to the data. So you can select like different data types and can very quickly configure it to support basically any kind of multimodal data, where obviously there are some data types that work maybe better than others. For example, our support for NLP currently is a bit limited, but there is, I think, no inherent barrier to use it for a specific data type or application. Where we are very focused on is that we only provide this data inspection, data curation layer. And by that, I mean, we don't want to build, for example, data management or versioning. We don't want to build the best algorithm that flags leakage or computes embeddings or explains features. We use what's available out there, or we teach our customers and partners to use this. And Spotlight really is this inspection tagging component in the data-centric AI stack. So we really try to focus hard on this, but we don't exclude like any data type or domain.
Cloud or on-site, where does it run? How does it run?
Thank you. So it's also historically, because our customers were at the time primarily the auto OEMs, it runs directly on the local machine. It's web-based, so there might be some version of it in the future that's hosted, but right now it runs on the local workstation, so it's completely on site and therefore complies like with all the data security and other issues that you typically have in industrial AI.
Yeah, we're not going to go into the details. We've done that many times before. Share with us, please, a couple of key aspects of you already mentioned the curation process, data creation process, and then relate them to, some of the features, maybe the USP of Spotlight.
Yeah, sure. So I also introduce it from a different perspective where I already said data inspection and tagging is so important. And I actually would like to support this with a quote that Greg Brockman, the CTO of OpenAI, did on Twitter this February. He said, manual inspection of data has probably the highest value to prestige ratio of any activity in machine learning. So we really feel like inspection is super underrated still. And that's why we feel it's important to have a good tool to do this.
Interesting to hear. You said many other things also related to ChatGPT and generative. We'll come to that towards the end as well. But very interesting to hear. That is an important point that he made as well.
Yes, I can go back to that. I think it's very interesting that even for these models, even for ChatGPT, this is a key aspect, right? So I think we have three things that we really focus on and where we really feel like a better solution is needed that we currently have. And the first thing I already mentioned this is you have to load your data with just one line of code. You have the data and then you have to give some semantics to it. You have to say, this is an image, this is an embedding, this is a video, and then you fire up the tool. And this has to be really simple, really quick. You don't have to change your stack too much. This is a pain point that many customers said, if I use this tool, I have to put it into the cloud or in a different database and my pipelines are breaking then. So this simplicity, I think it's super important. And the next step is that, as I said, it's multimodal. So it's very easy to configure it. And I think for many of the industrial AI use cases we did, this was important as well. That you just look at, for example, a connected car, you might have cameras, you might have different sensors, right? You might have logging data. So I think there are a lot of use cases for multimodal data there as well. And being able to configure it quickly is important. And the last point, and I actually think that going forward, this is the most important point, is what you can do. You can build this interaction templates. We call it recipes. And together with some pieces of code, you can build a recipe for a data curation step that might either be very general, for example, find duplicates in images, but this can also be very specific to an application or use case in a company. And we feel that having these recipes available is super important because there is so much knowledge about these different steps, both in terms of methods and and in terms of available libraries, that it's very difficult for teams to keep up, right? And I don't exclude myself from this. I have so many discussions with industry experts, and you cannot keep track of all the development and the library that's going on. It's impossible. It's going so fast. So the chance that you are missing out on something that's very valuable to you is, I think it's really high. And having the ability to capture these recipes as best practices, we feel is really important.
So bringing it all together, maybe you can give us an example on the use of a recipe, on the use of another thing. You call it industrial AI canvas, I believe, but maybe you can just give us an example, a use case. I think you've been doing things around AI-assisted engineering, but it would be nice in the industrial AI space just to walk us through how what person has been using your platform to boost the data quality.
Yeah, sure. Last year, actually, we looked a little bit deeper into acoustics applications. And in engineering, there are several use cases where you can use acoustic analysis. One is condition monitoring for machines. Another one is test data analysis. And this is actually important in the automotive industry. So you have test cars that drive around, and a very traditional mechanical engineering problem, you would like to detect and understand brake squeal. So you have some microphones that detect if the brakes are squeaking. And right now, this is a job that has to be done with a lot of manual work. There are some heuristic algorithm who might detect, it's a little bit loud and I hear it more. It's maybe a little like a high-pitched noise, stuff like this, but they're not reliable. So building a machine learning system is a good business use case for an OEM. And this is, I think, the first step where we use this industrial AI canvas. We have seen that it's very important. I think most people now do this, but to get the concept of your solution right, to understand what's the business value. This is one key area. Another key area is how should the user interact with the solution? And the third one is what kind of machine learning is required. And then you have like all these auxiliary things you have to think about. Where does my data come from? Do I have to put it in a database? Do I have to convert it? How does the operation look like? So getting the concept right, I think, is the first step.
Quick in between question. Is the idea that in the end, the car manufacturer is going to have an engineering change, or could this be, or is it maybe open? Could this be also a point of inference in the car? Like, when the brakes start squeaking, that whatever kind of variables, so to speak, are going to be changed such that it doesn't squeak anymore.
Very interesting. Very specifically, I'm not aware that you would use this, but I think the point is very valid. So in general, to make this tangent is we see many applications in industrial AI where a first step is to build an internal tool to, for example, optimize your testing process as you do it here. And the next step is to roll out functionality of this tool to a partner. For example, in this application, you might say, okay, I have this system that can detect or understand noises from the car. You might want to use this in a workshop for identifying errors, right? And the last step might be that you have, as an end user, have these tools available that can say, oh, well, I hear something very strangely in your car. You should put it in a workshop. I think maybe this is a little bit far-fetched in this example, but there are many examples like this. And I think it's a very good strategy generally to go from like internal tool with partners, tool to end customer.
And then, because you are the one introducing iterative, then, because I don't know the cycles, the development cycles of a certain car platform, if that's still 5, 6, 7 years, or it's coming down to years. And then you can give it, at first point, you can put it as an inference solution in the car. So to say, if you have a powerful hardware solution, you can update it over the air, for example. And then if it works fine, you're getting also in combination with making sure you boost your data, the quality. And then if it works fine, you can then, maybe it is a section of the engineering department anyway, and then they can decide that maybe in the next level, the next version of this car, so to say, they're going to do a small engineering change.
Yeah, sure. I totally agree. I think maybe want to jump on this point because I think it's so important. What we often talk about is like this data flywheels. You build building a machine learning based solution. And when you use this solution, it automatically gets better. For example, take this brakes wheel solution. When it's used, the system sometimes asks the engineer, is this okay or not? And it gets feedback and it automatically gets better. And then in the next step, you roll it out to your partners with the very same principle. And you have something that like where your data set improves and improves. And with that, your solution improves and improves. And you can roll out this to a customer and you get real competitive advantage, because by introducing this new solution, you're harvesting data that you can then use to improve the solution. And I think especially for machine manufacturers, for example, it's a very important strategy for the future, for building this new data-enabled functionality into their machines. And really thinking about these data flywheels and thinking about the long-term aspects and strategy, I think it's also important in this concept that we do with the industrial AI canvas, where obviously we want to really see will the solution work in a first iteration, what's the first ROI, but we also want to understand like where can we go with that. And I think it's a very important consideration. And it's also very important to say, okay, I want to get to something that works and brings value quickly, but I also want to see where like the large long-term benefits like are for the company.
Stefan, before Robert is going to slap me on my fingers again because my podcasts are too long, we need to come to a close. And I want to do that with asking you, we've been talking about indirectly, so to say, because, and then you can share that with us as well about your team, the people around you. I'm sure there are a number of people who have putting this all together. So software programming, software engineering. Now, there is not a day that I wake up, open my notebook. I typically go into LinkedIn, see what's happening. And every day, the world seems to have been put upside down. You know, ChatGPT, generative AI, suddenly there's plugins, there's forecasts that the cost of software programming, engineering is going to go down to zero in a couple of years. Let me have your experience. Do you experience that in a similar way? And if so, or if not, you know, what does all of this mean for you? And what we have talked about today in boosting the quality of data and, you know, in the end, the solution that you give to people.
Yeah, I totally agree. And when I saw this post about the cost of developing software will plummet, I was like, wow, this is crazy. And I agree that we live, I think, in very, very interesting times. I also have to admit that ChatGPT was, for me personally, the first time I thought, wow, this is gonna change everything. And like seeing this, how my parents, for example, use ChatGPT, like having this reach outside of the bubble, like where everybody in the population uses this technology now. I think it's amazing. And I think it's gonna change a lot. Maybe it changes everything. But I also have to admit that I'm like a little bit worried that there is too much hype. What we see actually at our customers is that the teams are telling us, well, our CTO or whoever says, what are we already doing something with ChatGPT? What are we doing in this area? So instead of having a use case and saying, okay, we apply machine learning to it, we go the other way around, or we have to do something with AI. And I think when we started in 2017, it was the same situation where you just wanted to fit in this technology. And I think this hype did a lot of bad things. I mean, if you, for example, look at autonomous driving, all the disappointment. And I think we should be careful, especially in industrial AI, not to generate like too much hype around it, but do the stuff that works and do small steps forward. And within these small steps, I'm absolutely convinced that really understanding data, very specifically unstructured data, inspect it, going from quantitative metrics to qualitative data understanding is key. And as I said, I think it's so refreshing to see that even if we're talking about large language models, we see that like the fine-tuning with very little, I would say, amounts of data, but very high quality, very highly curated data set currently seems to be the key for getting these great results. So I think this approach is important everywhere, and it's especially important in industrial AI.
Strong agreement there. And I hadn't heard the comment from Greg Brockman there. I'm getting more and more, how should I say, impressed also by the productivity boosting side of the ChatGPT. I've always said, as far as answering questions, there is a structural flaw kind of in this stochastic parrot, right? But, and then suddenly you see that you can plug in data. Now, if that plug in apps, right? So if that means that the apps you're plugging in, that they, which in the past has been, data from the web. So, some good data, some very bad data, bad in all kind of ways. And if that is what is changing. So nevertheless, I very much like what I hear from you talking about the small steps. I very much understand that you and many listeners are working in an environment where, on one hand, and it was the same for me, I think it was my son-in-law yesterday on a Sunday who was talking to me about ChatGPT. And I thought, what is this all about? And it's moving out there, and maybe it has been too fast. I don't know. We have to be very, very careful of the hype. But at the same time, of course, your potential customers are asking about, and I think all of us need to look into what is possible. But as you say, we should be very, very careful and make small steps, especially in an industrial or medical is another example, and many, but also many other areas. We need to make small steps just to make sure that what it is that we do gives a high quality result by and not forgetting boosting data. So Stefan, thank you very much for your time. Oh, we didn't talk about it. Listeners that want to get in touch with you, should they best do that on LinkedIn?
Yeah, obviously on LinkedIn, or you can also go on the website, and I'd be really happy to. I think we have a button, demo or coffee talk, so you can talk to me there as well.
So yeah, we'll put the details in the show notes. Stefan Suwelack, that's Suwelack, and Renumics is Renumics, Renumics. Okay, otherwise, if you, dear listeners, if you have any questions, comments, as always, please do send me an email, peter@aipod.de. I'm very happy that you stayed with us so far. Looking forward to have you again with us next time. And Stefan, thank you very much for your time and sharing your experience with us.
Yeah, thank you very much. Thanks so much for having me.
Bye-bye.
Bye.